All right, guys, it's Unit 8, Notes 3, where I talk about multiplying radical expressions. So, go ahead and pause the video here so you can jot this down, and then come back, and I'm going to talk about it. All right, hopefully you pause. So, multiplying radical expressions. You multiply the outside of the radical, so like that A times C, that red arrow, those are both outside of our radical. And then multiply underneath the radical. So that's like our B and our D, the blue arrow. Those need to be multiplied together. And then 3 says simplify the remaining expression. So if this B times D can be broken down like we did in 8.1 and we did again in 8.2, then you'd want to break those down. All right, so if we look here, we're going to go ahead. There's nothing outside of my radical, so we're just going to multiply the 2 times the 5. Can 10 break down into perfect radicals or pairs or anything like that? No, it can't. So then that's going to be our solution. All right, if we look at 2, we do have numbers outside. So we're going to take our 4 times 6, and we get 24. And then we're going to take our 3 times 2, and we end up with 6. Now 6, the radical of 6 doesn't break down, so then this ends up being our solution here. All right. Oh, now in number 3, we have 3 of them, and that's totally fine. We continue on. We multiply the things that are outside. In front of this would be like a 1. So we're going to take 2 times 1 times 4, and we get 8. And then we're going to multiply our values underneath our radical. 3 times 2 times 3. And so we get 12 here. And now we have to ask ourselves, well, can we break down 12? And yeah, we can. We can break 12 down, and I'm going to break down by perfect squares. We have 4, which is a perfect square, times 3. Okay, so we have 8 times the square root of 4 times the square root of 3. And the square root of 4 is 2. So now we just get 8 times 2, and we end up with 16. Square root of 3. Hold up, Miss Math, some different math from you guys. It should be an 18 under here, not a 12. Let's try that again. See, we all make mistakes. All right, because 3 times 2 is 6, times 3 is 18. Whoops. All right, so let's break that down again. 9 is a perfect radical, and 2. So we have 8 times the square root of 9 times the square root of 2. And the square root of 9 gives us 3. And 8 times 3 gives us 24 times the square root of 2. That's my answer. I'm supposed to have. I'm like looking at my answer key going, it's wrong. Why is it wrong? Okay, there we go. So make sure you erased or crossed out that previous work that we did and get that correct one. Sorry about that. All right, so let's go ahead here. We're going to multiply our outside numbers. So negative 6 times 4 gives me negative 24. And we're going to multiply our numbers underneath our radical here. And 5 times 15 gives us 75. 75 we can break down. Again, you want to be looking back at 8.1 at all those perfect radicals if you don't know them. I do have them written up in our classroom somewhere. So we get 25 and 3. So negative 24, square root of 25, square root of 3. That's a prime because it doesn't go further. And the square root of 25 is 5. All right, and now we're going to take our negative 24 times 5, and we get negative 120, square root of 3. All right, so pause the video, rewind the video, do what you need to get those down. Let's go ahead and add in some variables. It's the same thing. If it's underneath the radical, multiply with other things underneath the radical. If it's in front of a radical, multiply by things in front of the radical. All right, so here, everything's underneath the radical. So we're going to take 20 times 6, and we get 120. And then we're going to go ahead and multiply our x squared and our x, and we get x cubed. So then we go ahead and look here. 120 is a big number, and you're going to think about your radicals, perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. Okay, so actually, guys, the largest one that's going to break out of here is just going to be 4. It seems so little, but it's largest one that comes out. Okay, x cubed gets broken down into 3 x's, and so you have 1 pair. So we are going to have 2x square root of 30x. So some of you might be like, whoa, how'd you get there? All right, under our square root, we have 4, and then 30, because 30 breaks down into 5 and 6, and 6 breaks down into 2 and 3. So that doesn't go further. And 3 x's. So a pair of x's, and this 4, those are going on the outside, and the 30x gets left underneath. All right. Then, if we look at our next problem, we have a 4 on the outside, and then we're just going to multiply the inside stuff. So we get 54, a to the 4th. All right, so we're going to go ahead and break down 54, and the largest perfect square that comes out of that is going to be our 9, and 9 times 6. Now, a to the 4th is going to be 4 a's. So 4 on the outside, 9 times 6, and 4 a's. 1, 2, 3, 4. All right, so 9 is a perfect radical. 6 only breaks into 2 and 3. So remember, 6 doesn't break down further. And then I have 2 pairs of a's. So 4, the square root of 9 gave me a 3, and then I get 2 a's. And we get 6 left underneath. So just multiply everything in the front to be 12a squared, square root of 6. Now, some of you might have thought about these two problems and been like, hey, can I break down the radical first and then multiply? Yeah, that's totally fine. If you want to do that, you want to ask me about it, go right ahead when we get back to class together. Okay, let's look at this next one here. This one, now we're going to do some multiplying still, but we're distributing this time. So we get square root of 15, multiply that under the radical. Now the 3 is under the radical, but the 4 isn't. So the 4 stays out in front, and the 3 stays underneath. Now we got to ask 15, does that break down? Well, the only things it breaks down into is 3 and 5. So we can't simplify that, and square root of 3 stays as is. So this actually is already simplified. All right, number 8, we're going to distribute in. 2 is not underneath the radical, so it's going to be multiplied by this negative 3. So we get negative 6, square root of 3. Now we're going to distribute in. Negative 3 doesn't, it just has a 1 in front of the square root of 6, so we're going to just do this, negative 3. And then we're going to multiply our 3 and our 6 to get ourselves 18. Now my first term isn't going to simplify any because it's the 3 under the radical, so it doesn't break down any further. But my second term totally breaks down into a perfect square of 9 and 2. So I get negative 6 square root of 3, we didn't do anything there, minus 3. Now this perfect square 9 here is going to give me another 3 out front and leave a 2 underneath. So you get negative 6 square root of 3 minus 9 square root of 2. Those are not like radicals because they don't have the same thing underneath the radical. So there's our solution. All right, a few more problems here, ladies and gentlemen. We're going to do another one here where we're going to distribute. Now the 14 is under the radical and the 3 is not. So we get 3 square root of 14x minus, now the 14x and the 2x are both underneath my radical, so those can be multiplied. All right, so you want to see if you can simplify underneath your radical. I cannot break down 14 any further than 7 and 2, so there's no pairs. So that just is going to stay as is. 3 radical 14x. Okay, 28, though, I can break that down into a perfect square of 4 and then a prime number 7. X squared is going to break into 2 x's, so that's a pair. All right, so outside of my radical, the square root of 4 is 2, and I have a pair of x's, so I get an x. And all that's left under is square root of 7. 14x and 7 are not like things underneath the radical, so we're going to leave our solution. All right, number 10, one more like this. We're going to distribute. The 5 under the radical is going to be multiplied by the 2 under the radical, because we got to only multiply under radicals. The next one, this 4 doesn't have anything to multiply with, so minus 4. But we are going to multiply the 5 and 8 to get 40. Okay, so we know 10 does not break down. So the first term is going to stay as is. But the second term, 40, we can definitely break that down. So we're thinking perfect squares. 1, 4, 9, 16. And then this one, we're going to break it into 4 and 10. 4 is the largest perfect square that goes in. So the square root of 4 gives me an additional 2 out front. So this becomes an 8, negative 8. So 5 square root of 10 minus 8 square root of 10. And so now these are like radicals because they're the same thing underneath the square root. So we're going to take 5 minus 8, give us a negative 3 square root of 10. All right, again, pause the video, rewind the video, email me, reach out, let me know. Our last two problems here, worrying about two binomials being multiplied. So here, we either want to FOIL or box method. And I personally like FOIL, that's just what I grew up with, but you are free to do box method. So first would be 3 times 3, so we get 9. O is outside, so we get a negative, oops, because that was a minus 5x, so we get negative 3 square root of 5. 3's out under the radical, 5 is. Okay. Inside, now we're going to get a positive 3 square root of 5, and then last, square root of 5 times negative square root of 5 is negative. Now the 5's are both under the radical, so I can multiply those two. If you notice, our middle two terms are opposites, so these are actually going to cancel out. That happens when we have these what's called conjugates. So it's two binomials that are the exact same, but one's a plus and one's a minus. So these two are called conjugates. All right, so we have our 9 minus, now square root of 25, that is a perfect square root, so I can put 5. 9 minus 5 gives me a whopping 4. All right, last problem. Okay, so here I can multiply things underneath my radicals. All of them are under the radical. So 6 times 24, we get the square root of 144. And then I'm going to go outside. So 6 times 2 gives me the square root of 12. Inside, 8 times 24, I have the square root of 192. And then last, 8 times 2 plus square root of 16. Sorry, kind of got smushed. 144 and 16 are both perfect squares. So the square root of 144 is 12, and the square root of 16 is 4. Now I need to break down my two other ones. So 12, we can break it into 6 and 2, but 6 and 2 are neither of those are perfect squares. But I can also break it into 4 and 3, and 4 is a perfect square. So we get 2 square root of 3. The square root of 4 is 2. All right, that brings us to 192. Ooh, 192, there's got to be something in there. And 192 actually breaks down into 64 and 3. 64 is a perfect square. 3 obviously is not. The square root of 64 is 8. All right, so I have constants here in the 4 and the 12, so I get 16. And then I have like terms here, 8 square root of 3 and 2 square root of 3. Add to give me a 10 square root of 3. Now, pump the brakes, don't add the 16 and the 10. If it helps to write it like this, so that you don't feel it because you got that square root of 3 in there, that's fine. But both of those, I will accept for answers. All right, there you have it.